dear students, welcome back to NEET World. So today in this session we will be discussing stoichiometry. So we know there will be one 4 marks question from this stoichiometry in your final exam, in your final IPE exam, right? So now let us discuss about this question. Yes. Yeah. So today we will be discussing 4 marks. See, definitely there will be one question from stoichiometry in your 4 marks section right now. So let us discuss about this. Yeah. So before going to our discussion, see, this is our C60 material. Yes, you can access this C60 material for free of cost from our NEET World app. So just go to Play Store and download NEET World app. Okay, and after that you just log in using your mobile ID, your mobile number. Then after you just mention your class and group in the chat section. Then our team will guide you how to access this material for free of cost from our app itself. Okay, right. In the last class I have discussed this LAQ question, that is 8 marks question from this chapter itself, I mean this complete chemistry part itself. Okay, all the 3 questions, that is from section C we have 3 questions, right? So if you look at this, so this is chapter wise weightage here we have. So from this I have discussed all LAQs, 8 marks questions I have discussed, and 4 marks questions are also under discussion now, and few 2 marks VSAQ type questions are also discussed. Okay, if you haven't watched those sessions, you can just go through the playlist of this channel, live playlist of this channel, and you can watch all those and you can make your preparation more effective. Okay, right. In this discussion today, as I told you that I am going to explain you 4 marks from this is stoichiometry. Okay, so now first question here, mostly like out of 100% I can say mostly it will be 70 to 75% question comes only on this balancing the redox equation. Okay, it's very easy, just follow my discussion. See, oxalic acid is oxidized by permanganate ion in acidic medium to Mn+2. It means permanganate KMnO, like MnO4 converted into Mn+2. Now balance the equation in ion by ion electron method. So by following ion electron method, we need to balance this equation. See, as per them, what they are saying, just see here what they are saying. Permanganate ion is given. Okay, let me give you. This permanganate ion is given, and that is treated with oxalate ion. See, permanganate ion MnO4 minus and oxalate ion is reacting here. So now what happens, permanganate ion undergoing reduction. See in permanganate ion, manganese in +7 oxidation state. Okay, it's a very simple thing. First, whatever they have mentioned in the question, write in the equation form first. Okay, you have written in this form because permanganate ion in acidic medium to Mn+2 they are saying, yes, I have mentioned that. Next, oxalate ion will convert into CO2, carbon dioxide. So here +3 oxidation state of carbon will be converted into +4 oxidation state here. Okay, so this is what the conversion is taking place. Now you need to identify what is the reduction half, oxidation half reaction. See, permanganate ion converting into Mn+2 now. So number +7 is reduced, decreased to +2 now. So you can say this as a reduction half. What is this? Reduction half reaction. Now oxalate ion +3 carbon converting into +4 now. So number is increased now, +3 increased to +4. So you can say this as an oxidation half reaction. Okay, so this is the first thing you need to do, right? And after doing this, what to check here is, you just take the oxidation half separately, reduction half separately. Okay, so now I divided this equation into 2 halves. The first one is oxidation, OHR means what? Oxidation half reaction. What is the oxidation half reaction here? Oxalate ion converting into carbon dioxide. This is the half reaction, oxidation half reaction. Now what is happening here? So C2O4 converting into CO2. Now we need to balance this oxidation half reaction separately and reduction half reaction separately. Okay, right. Now how many carbons are there in the reactant side? 2. But product side only 1 is there now. Now what we need to do? Balance all other atoms other than oxygen and hydrogen. In this given oxidation half reaction, we have carbon, right? Other than oxygen and hydrogen, we have carbon only. balanced carbon. Now how can we balance? Multiply with a suitable integer wherever the carbon atoms are less. See here 2 carbons are there, product side only 1. So multiply product with 2. So C2O4, 2 minus become 2CO2. That's it. This is the first step. Okay. So in this way only step by step you mention in the exam to get good score. Okay. And after that, is there any hydrogens on reactant and product side? No, right? If in case if there is any hydrogens, no hydrogens and oxygens. Now first other than oxygen and hydrogen we need to balance. Carbon is balanced. That is over. Next one is to balance oxygen atoms. Okay. Now balance oxygen atoms. Okay. How can we balance? Just check here how many oxygens are there. 4 at the reactant side. Again that should be same on the product side also. 2 to the 4. Yes, 4 is there. Okay. What if there is any deficiency in oxygen? You need to add water molecule to the deficient side. Okay. Yes, there is no deficiency. No, so there is no need of bothering about that. Next, balancing hydrogen atoms. Yes. Do we have any hydrogen atoms at reactant or product side? No, no. So no need of worrying about that. Next one, balancing the charges. Now what is the charge present on the reactant side? See, C2O4 2 minus now. So same charge should be present on the product side also. See, CO2 is a neutral molecule. So what we need to make? So reactant side we have 2 minus charge. Okay. Product side also we need to make 2 minus charge. So for that reason I am adding here 2 electron. So electron, 1 electron minus 1 charge. So 2 electron minus 2. Reactant side minus 2. Product side also minus 2. Okay. So this is a basic step to be followed here. And after doing that, just go for the other. So we have balanced up to charges for the oxidation half reaction. Now come to this side, come to this side, come to this reduction half reaction side. See what is happening here. Just look at this. What is happening here? Permanganate ion MnO4 converting into Mn plus 2, right? So plus 7 is converting into plus 2, right? So this is what we are seeing. Now how many manganese atoms are there? Reactant side 1, product side also 1. That is perfect. Okay. Now balance oxygen atoms. Reactant side we have 4 oxygen atoms. Product side should also be 4 oxygen atoms should present. Okay. For that reason what I told you, wherever there is less in oxygen number, there that side we need to add water molecule. See here 4 oxygen atoms are there. So product side should be added with 4 water molecules. Okay, that's it. This is the important step to be remembered here. So wherever oxygens are less, that side we need to add water molecules. How many water molecule? The number of oxygen deficient, that many number of water molecules we need to add. So here I have added 4 water molecules. Therefore oxygens 4 reactant side, 4 product side. That is fine. Now if you consider here hydrogen atoms, we got here newly added hydrogen atom. How many are there? 8 hydrogen atoms are at product side, but there is no hydrogen atom at reactant side now. So wherever there is no hydrogen atom or deficiency in hydrogen atom, add H plus ion directly in acidic medium. See, this is in acidic medium now. So 8 H plus ions to be added at the reactant side. Therefore number of hydrogen atoms also get balanced. Okay, right. So hydrogen atoms balanced, oxygen atoms balanced, and manganese atoms, everything is balanced here. Okay, so atoms are balanced. Now what to need to check for? We need to look for the charges. Now what is the charge here? We have minus 1 plus 8. So it means reactant side plus 7 charge is there. Why I am saying plus 7? So minus 1 charge on manganate permanganate ion and H plus ions are 8. So 8 plus charges, 1 minus charge. So remaining is plus 7 charges there at the reactant side. Now come to the product side. Here you are seeing only plus 2 charge. Remaining is everything is neutral. So this reactant side plus 7, product side plus 2. So it means product side we are seeing less in charge. How much less? Almost plus 5 charges less. Okay. So this charge balancing should be done only by adding electrons. Okay. Now which side we can add in order to make the charges equal on both sides? See here plus 7 charges there now. So I can add plus 5 electrons, because if I add plus 5 electrons, so minus charge we are adding to the reactant side. So minus 5 plus 7, it becomes plus 2 now. Yes, plus 2 both sides is same. Okay, so that's why we got this equation. MnO4 minus 8H plus 5 electrons giving Mn plus 2 plus 4 water molecules. Okay, that's why we got this equation here. Right. Okay, so now one important thing I am going to tell you now. In the redox reaction, number of electrons participating in oxidation half reaction should be equals to number of electrons participated in reduction half reaction. But if you see in oxidation half reaction, we have only 2 electrons participated, but in the reduction half reaction there are 5 electrons involved right now. So these electrons are not equally balanced right now. Oxidation half only
the molecule,
but reduction half having.
and
So what
process is
we need to equalize that electrons. So how do we make that equalization? Yes, it's very easy. Now it's only 2 electrons here, there is 5 electrons. Now multiply this equation with the 5, oxidation half reaction with 5 and half reaction with 2. Why we are multiplying with 2? Because here 5 electrons, 5 2s are 10 electrons, it becomes a reduction half. Here 2 electrons multiplying with 5 becomes 2 5s are 10. So here also 10 electrons, there also 10 electrons. So total number of electrons in oxidation and reduction are getting equal. Therefore the equation will become, say I am multiplying with 5 now, so it becomes 5 C2O4 and it gives rise to 2 CO2 is there, 5 2s are 10, 10 CO2, 2 electrons are there, 5 2s are 10, 10 electrons we are getting. And here also multiplying with 2, this equation becomes 2 MnO4 plus 8 2s are 16, 16H plus 5 2s are 10, 10 electrons and 2 Mn plus 2, 8 4 2s are 8, 8H2, like that we are going to get. Okay, hope up to here the discussion is clear. Now if you observe, here 10 electrons are at the product side, but here 10 electrons at the reactant side. Now you just add these two equations. What happens by adding equations, this oxidation half final equation and reduction half final equation, this product side 10 electrons, this reactant side 10 electrons will be removed. Okay, not only electrons, if there is anything similar, anything same on reactant side and product side, that can be cancelled out. Okay, that's it. Okay, so final equation what we are going to get, see 2 MnO4, yes 2 MnO4, here 5 C2O4 2 minus, yes, the next 14H plus, yes 14H plus. Is there any remaining thing towards the reactant side? No, because electrons get cancelled out. Okay, so 10 giving rise to 10 CO2, yes 10 CO2 plus 2 Mn plus 2, okay, plus 8H2O, yes, we got our final equation. So this is a balanced chemical equation, balanced redox reaction equation in ion electron method in acidic medium. Hope the discussion is clear. Guys, if the discussion is clear, just hit on the like button once so that I can confirm you are following the session. Or if there is any confusion, please let me know in the chat box. I will definitely give you the repetition of that discussion. Yes, tell me anyone. In the chat box, I am looking into the chat box. Any confusion, please feel free to express. Yeah, let's move forward. The next question here we have is balance the following redox reaction by ion electron method in acidic medium. Again, same concept but different question. Okay, see whatever I am showing the questions here, those are previously asked questions only in your IPE exams. Okay, so you should not skip any of this question. If possible, try to do more the number of questions, like more number of examples once after completing this discussion, because this chapter, this concept, this balancing of redox reaction is equally important if you are preparing for NEET, JEE or EAP set kind of exams. Okay, yes, you can see any of the paper, definitely will be having a question on this. Okay, so it's very important to understand the concept of balancing redox reactions using ion electron method and also oxidation number method. Okay, yes, for competitive exams you just follow some simple tricks, but here you need to write in detailed answer. Okay, then only you will get good marks, right? Now read the question once again. Balance the following redox reaction by ion electron method in acidic medium. So the scenario will be different in acidic medium and in basic medium. Next question I will tell you about basic medium, but listen to this particular one. Okay, now what I told you, first write the skeletal equation they have given. Okay, and while writing your answer in the final exam, you need to mention everything in detail. Point number 1, write the skeletal equation for the given redox reaction. Yes, we have written the skeletal equation. Now second point, assign the oxidation states for the species undergoing oxidation and reduction. This is the second point. Now write the equation and assign their oxidation state. So 2 points over. Next, identify the oxidation half, reduction half. Okay, yes. Now tell me, what is the species undergoing oxidation and reduction here? Here if you find permanganate ion again, so permanganate ion is having how much charge? So it is +7 oxidation state. Here +4 for sulfur dioxide. Okay, and what about this manganese +2 and HSO4 here again +6. Okay. Now tell me what is happening here. So +7 is converting into +2. This is a reduction half reaction we got. Okay, and whereas +4 is converting into +6, this is oxidation half reaction we have. Okay, so most of the cases by default you consider first oxidation half, then next reduction half. Okay, that will be more appropriate consideration. Okay, so now look at here. Yes, you can take in both the ways, but write oxidation half, next reduction half. Okay, so we are writing skeletal ionic equation we have written. The next identified species undergoing oxidations and reductions. Okay, next half reaction. What is the oxidation half reaction we have? See, which is undergoing oxidation? SO2 converting into HSO4 minus now. Yeah, take that. SO2 giving rise to HSO4. Okay, now what to do? Once after writing oxidation half reaction, balance other atoms, like all other atoms except oxygen and hydrogens first. Okay, now balance all other atoms except hydrogen and oxygen. Okay, now sulfur, how many are there in the reactant side? 1. Product side also 1. Yes, sulfur is balanced. Next, what next here? Yeah, so look at the oxygens. How many oxygens are there here? 4 oxygens at the product side, but only 2 oxygens at the reactant side. Now what we need to do? Add the number of deficient, add the number of water molecules that is equals to deficiency in the oxygen. How many oxygens are deficient here? Here 2, here 4. So 2 oxygens are deficient at the reactant side. So that's why I am adding 2 H2 at the reactant side. That's it. So SO2 plus 2 H2O gives rise to HSO4. Okay. So number of oxygens are balanced, sulfurs are balanced. Now what else is remaining? Hydrogens. How many hydrogens are there? So at the reactant side we have 4 hydrogens, but product side only 1 hydrogen is there. So what we need to do? Add the hydrogen atoms like H plus protons wherever deficiency in the hydrogen. So I can write this as SO2 plus 2H2O gives rise to HSO4 minus. Okay, this is fine up to here. How many hydrogens are there here? 4 now. Only 1 is there at the product side. So add 3 H plus ions. Okay, so once after adding these 3 H plus ions, yes, hydrogen atoms are balanced. Now after this, what I told you, now we need to balance charges. What is the charge we have reactant side? No charge. But product side there is 3 plus charges and 1 minus charges. It means what is extra here? What is extra here? Plus 2 charges extra, na? Minus 1 plus 3. How much? See, plus there are 3 H plus ions. So H plus ions are there. So 3 plus charges, 1 minus charges there. So remaining is plus 2 now. So for that plus 2, in order to make it equal on both sides, I need to remove that, neutralize that plus charge. So for that I am adding here 2 electrons. Now what happens? 2 electrons, minus 2 plus minus 1, it means minus 3, it is plus 3. So it is neutralized. Okay, charge is balanced. Okay, so this is how you need to balance oxidation half reaction. Now we need to go for the reduction half reaction. What is the reduction half reaction we have? What is the reduction half reaction we have? Yes, so I am erasing this. Let us move forward. Yeah. So what is the reduction half reaction here? See, this is what the equation we got in the previous slide. We show that. What is the equation we got? Oxidation half final equation. SO2 plus 2H2O gives rise to HSO4 minus plus 3 H plus ions plus 2 electrons we got. This is the oxidation half final equation. Now look at the reduction half reaction. See what is happening? MnO4 converting into Mn plus 2, right? So plus 7 oxidation state converting into plus 2. Now how many manganese are there? 1 at the reactant side, 1 at the product side. That is fine. Now how many oxygens are there? reactant side 4 are there, product side 0. So what we need to do? We need to balance oxygens by adding water molecules. Now where do we need to add water molecules? To the deficient side. Where it is deficient? Product side. So how many deficiency in oxygen? There are 4 oxygens in the reactant side. So you add 4 H2O at the product side. So we got, see, balance oxygen atoms by adding H2O. So MnO4 giving rise to Mn plus 2 plus 4H2O. Yes, 4H2O is added. That's it. Now oxygens are balanced. Now what next? Hydrogen should be balanced. How can we balance these hydrogens? Yes, directly add protons, H plus ions, wherever it is deficient. Okay. So now here we have 4 to the 8. 8 H plus at the product side, 0 H plus at the reactant side. So just add 8 H plus at the reactant side. Therefore everything is get balanced here. All the atoms are getting balanced here. Just check Mn, Mn, O4, 4 oxygens. 8 H plus, 8 H plus. That's it. Okay, everything is balanced. Now what next? Atoms are balanced. Now what next? Charges should be balanced. Now what is the charge we have at the reactant side? See, there is 1 minus and 8 plus. So plus 7 charge is there at the reactant side. Now product side, if you see, just plus 2 charge is there. So how can we make it equal on both sides? By adding electrons. Which side we need to add? Since electrons are minus charges, we need to add this more positive side. Okay, so 5 electrons I am adding. So 5 minus charges, 7 plus charges. So it becomes a plus 2 at the reactant side, plus 2 at the product side. That's it. Okay, so we have charge balanced up to here. So MnO4 minus plus 8 electrons plus 5 8 H plus 5 electrons giving Mn plus 2 plus 2H2. Okay, up to here it is balanced in the next. What to do? Yeah, so take oxidation half, reduction half. Look at their electrons. How many electrons involved in the oxidation half? Only 2 electrons. But in reduction half, how many electrons are involved? 5 electrons are involved. So these numbers are not equal now. So equalize the number of electrons involved in oxidation half, reduction half. Okay, this is the main step to get the perfect answer. Okay, equalizing the electrons. So for that purpose, what I should do? See, I have taken here 5 electrons, but there we have only 2 electrons. So you just multiply this equation with 2 and this equation with 5. Therefore, overall number of electrons here becomes 10. There also becomes 10. 2 5s are 10. 2 5. See, 5 2s are 10 and 2 5s are 10. So electrons are equal at reactant and product side, oxidation and reduction half. So equal. So they can get cancelled out. There is no electrons present in the final equation. Yes, in a redox reaction, the final equation does not contain any electrons. Okay, should be only atoms or ions or the molecules or species like charges, like ionic charges only. No electrons should be written in the final equation. Now see, multiply oxidation half with 5 because here 2 electrons are involved. No? That's why we should multiply with 5. Okay, and reduction half reaction with 2. Therefore, we will get the final equation. So 5SO2 plus 10H2O giving rise to 5HSO4 plus 15H plus and 10 electrons like this. Okay, is this clear? Right. We got these 2 equations after multiplying this with suitable numbers. Okay, so now this use these 2 suitable numbers. Okay, use these 2 suitable numbers. Now add them. Like add these 2 equations, electrons cancel. Next see, reactant side H plus ion, product side H plus ion. Yes. How many are there? 15 and 16. So 15 cancel, only 1 H plus ion is remaining. Okay. Like that, if you take the final equation will be looks something like this. Looks something like this. See, final equation will be like this, something like this. See, 2 MnO4 plus 5 SO2 plus 2H2O plus H plus giving rise to 2 MnO2 Mn plus 2 and 5 HSO4. This is the final equation. Have you observed this? In the final equation there is no involvement of electron right now. So electrons getting cancelled out in the last year. Okay, therefore we get an equation like this by adding both reduction half and oxidation half reactions. Okay, right. Let us move forward. Yeah, let's move. Yeah. So now look at the third question here. What we have? balance the following equation in basic medium by ion electron method. So this equation should be balanced in basic medium by following ion electron method. So here what we can do, same, write the skeletal equation first and assign their oxidations, and now make the separate equation, oxidation half reaction, reduction half reaction. Okay, so separate into two halves, one is oxidation, reduction. First write the oxidation half. See, I minus is converting into I2. Yes, this is oxidation. Okay, so minus 1 charge is converting into 0, so oxidation. Now what is about the reduction half reaction? MnO4 minus converting into MnO2. Okay, plus 7 is converting into plus 4. So this is a reduction half, na? Yes, that's it. Next, balance the atoms other than oxygen and hydrogen. Now what are the other atoms we have other than these two? In oxidation we have only iodide and iodine. So it is no oxygen and no hydrogen. Just balance them. So I minus converting into I2 means we require 2 iodide ions. So I2 I minus giving I2. Okay, that's it. When it comes to reduction half, say if you see manganese reduction half, only one manganese at reactant side, one manganese at product side, manganese is balanced. Okay, now next what to balance? Balance oxygens. Okay, so oxygens, just check oxygens are balanced or not. See, in this oxidation half no oxidation half no oxygen atoms are involved, but in reduction half we have. So MnO4 converting into MnO2. Okay, but if you see the reactant side, there are 4 hydrogen atoms, oxygen atoms, but product side only 2. Now what to do? Yes, add water molecule to the deficient side of oxygen. So wherever there is deficiency in oxygen, there you add water. See guys, whether it can be acidic medium or basic medium, up to here it is completely same. Okay, but after that, whenever we are adding H plus ions in that acidic medium, that is different case, because directly we are adding H plus ion wherever it is deficiency. But in basic medium we should not add H plus, because it is not acidic medium, no? So there is no H plus ions. It's a basic medium. We have only OH minus ions. Now here with the help of OH minus only we need to balance the protons. Okay, so now wherever there is deficiency in hydrogen atoms, balance the hydrogen atoms by adding OH minus ions. Since this is a basic medium, we need to add only OH minus. Okay, see how can we balance this? Listen here very carefully. Adding H2O molecule to the deficient side of H plus ion and same number of OH minus in the opposite side as shown. See, if you look at this, there is 2 H2O. It means 4 H plus ions at the product side, but reactant side no H plus ions. Now what we need to do? Add water molecules this side now, and same number of OH minus on the opposite side. See here how many H plus ions are less here? 4 now. So I am adding 4 water molecules to the reactant side. Same number of OH minus ions at the product side. That's it. Now check once everything is get balanced. See 4 to the 8 hydrogens, 4 2 to the 4 plus 4 hydrogens, 8. Okay, this side 4, that side, this side 8, this side 8. So H plus ions are also balanced. Now check oxygens, 4 plus 4, 8 oxygens here also, 2 plus 2, 4 plus 4, 8. Oxygens balanced, manganese, yes, everything is balanced. Okay, now what next? All the atoms are balanced now. Now what next? Charges. Okay, charges. See, again if you see, there is one observation to be done here. See, there are 4 H2O molecules at the reactant side, 2 H2O molecules at the product side. So whenever there is a duplicacy or whenever there is a possibility to remove, yes, so you can cancel out this 2 H2O, out of this 4 H2O we can remove 2. So final equation becomes MnO4 plus 2 H2O gives MnO2 plus 4 OH minus. That's it. Okay, up to here it is clear. Now balance the charges. How can you balance the charges? See, it's very easy, I will tell you. Yeah. So now see, oxidation half 2 I minus is there now. So converting into I2. So it means reactant side minus 2 charges there. Minus 1 like iodide ion. So minus is there. How many are there? 2. So minus 2 charges at reactant side. Product side should also be minus 2 charge. That's why we are adding 2 electrons at the product side. That's it. Okay, that is done for oxidation. Now look at the reduction half reaction. See how much charge we have at the product side. See, minus 4 charges at the product side, only -1 charge is at the reactant side. It means where do we have less charge here? Yes, see, charge should be balanced only by using electrons. Okay, here -4, here -1. So in order to make these numbers equal, so I am adding 3 electrons at the reactant side. Now what happens? So -1, -3. So that is -4 at the reactant side, -4 at the product side, like that. So final equation becomes MnO4 minus plus 2H2O plus 3 electrons gives MnO2 plus 4OH minus ions. Okay, that's it. Okay, charges balanced, electrons now charges balanced, atoms balanced right now. So now what next here? In oxidation half, how many electrons are involving? Only 2 electrons are involved. But in reduction half, there is 3 electrons involved. See, these numbers are not equal now. We need to make that equalization of electrons participated in oxidation, participated in reduction. So only 2 electrons now, just multiply with this 3 and this multiply with 2. Therefore overall electrons involved, it becomes 6. Here also it becomes 6. So 6 electrons in oxidation, 6 electrons in reduction get cancelled out each other and we will get a final equation. Okay. So if I multiply oxidation half with 3, what it becomes? 2 3s are 6. 6 iodide ions giving 3 I2 plus 6 electrons. That's it. This is oxidation half. Now next, this equation should be balanced multiplied with 2. 2 MnO4 minus giving 4H2O plus 6 electrons giving 2 MnO2 plus 8 OH. Okay, that's it. We got these 2 equations now. Now just add those 2 equations. See, product side 6 electrons, reactant side 6 electrons, remove. So what we are remaining with? See, 2 MnO4 minus 6 iodide ions plus 4H2O giving rise to 2 MnO2 plus 3H2, next 8 OH minus. This is our final equation. That's it. Okay. Hope the discussion of ion electron method, the balancing of redox reaction using ion electron method is clear, right? And the next one here is, again guys, once again I am reminding you, you need to learn oxidation number method also. In this material I have provided ion electron method. Okay, so try to get the concept of oxidation number method also. Yes, if you wanted to learn oxidation number method also, you just go through this channel playlist itself. I have made multiple times, 2-3 times I have made balancing of redox reaction for oxidation number method in the redox reaction chapter while discussing for NEET, JEE and EAP set concepts. Okay, yes, you can learn, you can watch that and you can make your preparation from that also. Okay, right. Next one here, yeah, this is also most frequently asked question only, like this, They will give the percentage of atoms and they will ask us to find empirical formula, molecular formula. It's very easy and equally important for your NEET, JEE and EAP set exams. Okay, yeah. Guys, from this, particularly from this chapter, whatever you are preparing for your IPE exam, those are highly helpful for your competitive exams also. Now, that balancing equation is like really it is too much important, and this equation also, this calculating empirical formula, molecular formula also very important. So just listen to me, I will explain. See, the question says here, a carbon compound contains 12.8% of carbon. Okay, a given organic compound might be, it contains how much? It contains how much? 12.8% carbon, okay, and 2.1% hydrogen and 85% of bromine. That's it. This is the data they are given. So just take a table. What are the elements they mentioned? Carbon, right? The carbon, hydrogen, and the next one is bromine. Yes, you write it like this. And what are the percentages they have mentioned? See, this percentage by weight. Just take here 12.8, 2.1, 8.5. You just make it as a tabular form. Okay. Now what you need to take is, this is weight of the species, weight of that carbon, hydrogen, bromine is given. So what do we mean by this 12.8% means? It means if you take 100 grams of that organic compound, whatever the compound they are saying, if you take 100 grams, in these 100 grams you will get 12.8 grams of carbon. How much quantity of carbon is present? 12.8 grams of carbon is present. So I am writing 12.8 and hydrogen is 2.1 and bromine is 85.1. Okay, that's clear. Next, what are the atomic masses or atomic masses for these elements? Okay, so for carbon it is 12 we know, and for hydrogen it is 1, and for bromine it is 80, right now. So now just find number of moles of carbon, number of moles of hydrogen, number of moles of bromine. How can you find? Number of moles is given by weight of that species by its atomic weight or atomic mass here you can say. Okay, so the given weight is 12.8 by 12. So 12.8 divided by 12. So this almost equals to 1.067 now. So let us consider the number it as 1. Okay, I am taking this as a number 1. Okay, now yeah, just see. And for example, hydrogen is there. How much mass they given? Given weight is 2.1 and its atomic weight is 1 only. So it becomes number of moles as 2.1 only. For bromine also, if you take 85.1 by 80, you get around 1.063. Now what you need to do is just divide these numbers, whatever the moles we got now. So just divide all these moles with the simplest number in all of these. So what is the simplest number we have? Yes, this one now. Yes, divide all this with 1.063. This is also 2.1 by 1.063. 1.067 is then divided by 1.063. So that you will get here carbon as 1, almost 2.1 by 1.063, almost 2 it will be, and this will be almost 1 here. That's it now. Yeah. So it means carbon atoms are 1, hydrogen atoms are 2, bromine atom is 1. Like this we are getting the formula. See, bromine is 1. Bromine is 1. So this is the empirical formula we got from the this data quantity they have mentioned. Okay, that's it. This is the empirical formula. Now if they provide little more information about this, if they see sometimes they will ask only for calculating empirical formula. Now sometimes they will also mention its molecular formula. Its molecular formula we need to find by looking at its molecular weight. They will say molecular weight is something around, given here it as 188, let us say N88, 187.9, let us say 188 grams it is given. Okay, so now just look at this empirical formula. C1, 1 carbon means it is 12, 2 hydrogens means 2, each one is 1, and 1 bromine is 80. So what we are going to get here, this is 92, 94. So the total mass is 94 we got. Atomic molecular weight of this empirical formula weight is 94. So just remember, empirical formula molecular formula of a substance will be equals to empirical formula into n times. Okay, now you are going to get this n value. See, just divide 188 by 94. So now what happens, it will be around 2 times. Okay, your n value we got it as 2. So now what happens to the empirical molecular formula? So it will be multiply this empirical formula with the molecular formula. Empirical formula with n, so that you will get molecular formula. See, molecular formula is equals to n into empirical formula, right? So what does it mean by empirical formula? The simplest whole number ratio of the elements present in that compound. Okay, now what about molecular formula? It tells us exact quantity of atoms of each element present in that molecular formula. Okay, so here n, how much n here? 2, and empirical formula is CH2Br. So what is the final formula we got? C2H4Br2 will be your final molecular formula of this compound. Okay, hope the discussion is clear. Up to here it is clear now? Yes guys, if this is clear, just click on the like button and you can share your feedback in the chat box. If there is any confusion, yes, feel free to express. Feel free to write in the chat box. I will definitely look into it and I will make it more clear based on your response. Right, next. Yeah, and once again I am saying, yeah, this is everything, whatever I am explaining, everything is there in this material. You can access this material for free of cost from our NEET World app. Just go to Play Store, download this NEET World app, log in and download our this PDF and make your preparation. Use it for your preparation purpose. Okay, and if you are really not knowing how to download it, just contact our team through the chat box itself. Just go to chat section and say how to access this. They will guide you how to access this. Okay. Now I am giving you an extra question. See, in the book itself I have provided, try this question also, but here I will be explaining the same question here. Just see what I am explaining. Data is nothing like only we have complete data, but answer here I haven't provided because I know you need to practice this on your own. Okay, but final answer I have given you. Okay, so how can you do this? See how much the carbon, the given compound contain how much hydrogen? 4% right now. So hydrogen, carbon and chlorine, these are the three elements given. I told you to write elements first. And what is the percentages they given? This is 4.07 and carbon is 24.27 and chlorine is 71.65. That's it. This is a weight percentage. From that I am getting the weight of each element in the 100 grams of this given substance. Okay, right. Now how many moles I want to get for each of the species? Okay, now what you need to do? Given weight by its atomic weight. So 4.07 by 1. Okay, because atomic weight of hydrogen is 1, and for carbon 24.27 by 12. Okay, because 12 is atomic weight of carbon. Okay, and for chlorine 71.65 by 35.5. Okay, this is atomic weight of chlorine. Okay, so like this hydrogen, carbon, chlorine is written. So just simplify this. You are going to get here 4 around, and this will be 2 around, and this will be around 2. So it means what we got? C2, carbons are 2, hydrogens are 4, and chlorines are 2. Like C2, H4, Cl2 we got. Now find its this is the empirical formula. Let us check whether its molecular formula is same or not. Okay, because they are saying find its empirical formula and molecular formula, and they mentioned molar mass is 98.62. Now find the molar mass of this substance. See 2 carbons now, so 2 into 12, that is 24, plus 4 hydrogens, 4 into 1, it's 4, and 2 chlorines, each one is 35.1, 35.5, so it becomes 71. So add this, it becomes how much? It becomes how much? How much it becomes? See 95 and 99, around 99, yes. So even empirical formula weight, molecular formula weight, molar mass, both of them are almost equal now. Yes, if they are almost equal means empirical formula and molecular formula is same for this particular compound. That's it. So what is the final formula we get? I mean molecular formula we got C2H4Cl2. This is a molecular formula. Now try to write the simplest whole number ratio for this. Right. So C2 is there now. So C, H4 is there now. So 4, Cl2 is there. So can I remove 2 as a common factor here? Yes, I can remove 2 as a common factor. So we got CH2Cl is the empirical formula. This is the empirical formula, and this is our molecular formula. Yes. So how can we decide an empirical formula and molecular formula? Yeah. So look at the formula we got. If that is the simplest whole number ratio, you can say it is an empirical. If that is not the simplest ratio, it can be considered to be a molecular formula. Yes, I am considering this as a molecular formula because its molecular formula weight as provided in the question, it is perfectly syncing. Right? Now we need to get empirical formula. Take the whole number, simplest whole number ratios of the elements. Yes, we got CH2Cl. Okay, twice. Why? Because 2 I can take as a common factor. So in value is here 2. That's it. This is about the chapter, that is stoichiometry. Okay, hope the discussion whatever we did from last 30 minutes is clearly understood or clearly followed by each and every student who are watching. Okay, right. If there is any confusion, feel free to express in the chat box. I will be giving you the clarity on them in the upcoming sessions. Okay, so thanks for watching. You can share with your friends who are preparing for NEET, JEE and EAP set exams also along with this IPE, because along with these IPE sessions we will be doing EAP set and NEET sessions also regularly. Daily we will be providing one live session, free live session in this YouTube channel itself for all the subjects. Okay, if you are an MPC students, yes, maths, physics, chemistry. By PC students, bio, physics and chemistry will be provided. Okay, right. So just click on the subscribe button and stay connected with our channel. Thank you for watching.